Hey there, this is Mr. Smith, and I have two problems that I want you to solve with this video that I'm going to show you. The first one is, what is the rotational inertia of this bicycle wheel right here? So this little mass is going to fall to the floor. I'm going to let my finger off of the wheel, and it's going to accelerate downwards. And you can actually see the velocity time graph for the motion of this little mass right below this video. And so as this, accelerates downwards, and you'll see that here in a second. Okay, you'll see the motion of that in the graph. So it's important to realize that that graph is not for the wheel itself, but just for this little mass as it accelerates down. You'll need to know the radius of this bicycle wheel is about 0.3 meters, and you'll also need to know the mass that's hanging on the end of the string here is 0.1 kilograms. And so we'll just play this video real quick so you can see it's not super exciting. The mass just falls down to the bottom. Okay, and so again, that's the first question is just what is the rotational inertia of that bicycle wheel? The second question is what would happen to the graph that you see below this video, the velocity time graph, how would that change if everything was the same mass of the wheel, the same mass hanging off the end, but the only thing that was different was the radius of the wheel. So if we had a string coming off of this with the same zero point 0.1 kilograms and the same mass of the bicycle wheel, we didn't change that, but we changed the radius of that bicycle wheel, how would that affect the graph that you see below? How would that affect the linear acceleration of the mass and the angular acceleration of the bicycle wheel?